Hi, in this lesson we will be covering Pythagorean Theorem. So let's begin. Okay, so the side opposite the right angle, or 90-degree angle, which is the longest side, is called the hypotenuse, whereas the two short sides are the legs of the triangle. Okay, and so the Pythagorean formula states that in a right triangle, the length of the hypotenuse is equal to the length of one side squared plus the length of the other side squared. And so the formula is as follows: c squared equals a squared plus b squared. Okay, and so if you take a look here at the figure of the Pythagorean theorem, we have the area of the square on the hypotenuse, which is equal to 25. And that's because 3 squared is 9 and 4 squared is 16. So as you can see, 25 is equal to 16 plus 9. All right, and so if you take a look, we have 25 squares in this one large square right here because we simply squared 5. Okay, and we squared 4 to get 16, and the same thing with 3 squared to get 9. Okay, so now sometimes it may be necessary to solve for the length of a missing length of a leg, and it's just like solving an equation. So let's go over some examples. So for example 1, we have to find the hypotenuse of this triangle. So let's go ahead and utilize the formula c squared equals a squared plus b squared. So what we're going to do is substitute the values in this equation and square the numbers. So let's just bring down c squared is equal to a squared, which we'll say is 5 squared, plus b squared is 12 squared. So now let's go ahead and calculate. So we have 25 plus 144. Bring down your c squared, and we're going to add 25 and 144, which equals 169. So we still have to isolate c in order to find out what the hypotenuse is. So in order to isolate c, we have to do the opposite of squaring, which is taking the square root. And remember, whatever you do to one side, you must do to the other side as well. And so if you notice, there's an unwritten 2 right here, so that means they cancel. So we are left with c is equal to the square root of 169 is 13. Therefore, the hypotenuse here is 13. All right, so now let's go and work out another example. So for this example, we have to find the length of side B of this triangle. So let's go ahead and do that. Let's first use the formula c squared equals a squared plus b squared. So let's substitute our values. So we have 17 squared equals a squared, which is 8 squared, and bring down your b squared, because remember, we're trying to find out what b is equal to. Okay, so let's go ahead and calculate even further. So 17 squared is equal to, let me bring that over here, is equal to 289, and that's equal to 8 squared, which is 64, plus b squared. Okay, so now we still have to isolate b. So we still have to, what we have to do is subtract 64 from both sides, because remember, this is a positive 64 and the opposite of a positive is a negative. So let's subtract 64 from here on this side as well as on the left side. So now you can calculate negative 64 plus 289, or 289 minus 64 is 225. And that's equal to, the 64's cancel, b squared. So now, since we still have to isolate this b, we have to take the square root of 225 as well as b squared. So the square root of 225 is equal to 15. And that's equal to b. So b is 15. Okay, so another thing I would like to mention is that in these last two examples we just covered, we used a couple of what's known as Pythagorean triples. Okay, so these were, some common ones that we've used. And Pythagorean triples always make right triangles. So these are positive integers that fit the formula c squared equals a squared plus b squared. So the numbers don't consist of decimals, fractions, or even radicals. They're simply whole numbers. So it's good to commit to memory some Pythagorean triples, because it'll help you find out what the correct leg, or what one leg is, or what a hypotenuse may be. So for example, let me go over some common Pythagorean triples you may come across. And actually, let me go ahead and wipe this out so I have more room. So we said that b was equal to 15 here. Let me just circle that. But anyway, some common Pythagorean triples you may want to commit to memory are 3, 4, 5, as well as 5, 12, 13, 6, 8, 10, 8, 15, 17, and 9, 12, 15. So if you actually knew the Pythagorean triples for this right here, you would actually be able to see that it's 15 without solving, right? Because if you notice right here, we have 8, 15, 17. And so since we have the 8 and the 17, well, then you would have figured that the other missing side was 15 because of this Pythagorean triple right here. So hopefully this lesson was helpful to you, and I look forward to working with you in the next lesson. Take care.